Fusion Mobile, quality e-learning experience on the go.
Hello and welcome to today's class. We'll be talking about group data for our topic today. Alright, our topic today is captioned group data, and under group data we'll be considering mean, mode, like I told you. Alright, the mean of a group data is given as summation fx all over summation f. Okay, good. Where f is equal to frequency of each data. Okay, all right, of each sample. All right, sample data, and then x is the sample data. All right, and then we have the summation sign. This is summation, okay, which implies that we have to sum the numbers, all right, or the figures we have. And then the median of a group data is defined as BC, okay, plus n over 2 minus f of m minus 1 all over fm, okay, and then bracket of c. All right, and here we have that BC is the lower class boundary. Okay, BC is the lower class boundary, boundary of the median class, all right, okay. And then we have that n is equal to the total number of observation, okay, and fm is equal to the frequency of the model class, okay. And then we have fm minus 1 denoting the frequency, of the class before the model class, frequency of the class, okay, before the model class. All right, and we have that's all, okay. And then the mode of a group data is given as L1 or L plus fm minus fm minus 1, okay, divided by fm minus fm minus minus 1, okay, in bracket plus fm minus fm plus 1, okay, times c. All right, so we'll describe the parameters we have here, where L is the lower class boundary, okay, and fm is the frequency of the model class, okay. And then fm minus 1 is equal to the frequency of the class before the model class, okay. And fm plus 1 is the frequency of the class after the model class, frequency of the class after the model class, okay. YC is the class width or the class size, all right. And so we shall as well use this method to define the median and the mode, and you already know how the mean is determined. Alright, so we'll go back to the previous table we had previous tables. Okay, and then we'll go back to the previous table. Alright, we're using this same table, and we'll only be interested on the columns containing the class mark, just for illustration. Okay, and the frequency. Alright, so the class marks, we have 9.5, 11.5, 13.5, and so on. Okay, right, for the class marks here, we'll pick the class marks 9.5, 11.5, we have 13.5, and then 15.5, 17.5, 19.5. Alright, I think that's correct. Okay, yes, 19.5. And then for the frequencies, we have 5, 4, 12, 15. Okay, 5, 4, 12, 15. I think that's right. 5, 4, 12, 15. And so for the frequency side, we have 5, 4, 12, 15. We have 12, and then the last number there is 2. Alright, the last frequency number there is 2. Okay, so we can go ahead to form f of x. Okay, f and x, f of x, which is multiplying each number. Multiply x and f, will have these values: 9.5 times 5, 47.5. 11.5 times 4 gives 46. 13.5 times 12, 162. 15.5 times 15, 232.5, and then the rest till you get to the last point, the last class mark. And so we start to compute by adding together the values of fx. Okay, so that we can get summation fx. We have 47.5 plus 46 plus 162 plus 232 plus 232.5. okay, plus 232.5 plus 210, and so and plus 39. When we add them together, we'll have 737. Right, and then we sum the frequencies. We have 5 plus 4 plus 12 plus 12 plus 15 plus 12 again. Alright, plus 2. Wow. And so we have that the total number of frequencies is equal to 87. Okay, is that what we had previously? Nope. Okay, we had the total number of frequencies to be equal to 50. Let's add again. We have 5, we have 4. 5 plus 4 is 9, plus 12 is 21, and then plus 15 we'll have plus 12 again. We have 48, then plus 2. Alright, that's 50. So this is wrong. Alright, so the next column we will actually have something, but not for this. We'll have something, but not for this. So from here we have summation f equal to 50, and then this gives us summation fx equal to 737. Alright, let's quickly define the variance for the group data. The variance for the group data is given as summation f into x minus x bar all over summation f. Alright, okay, so we have summation f into f minus x bar all over summation f. And so do we really have an x bar here? Okay, our x bar, which is defined as x bar, which is the mean. Okay, mean is given as summation f of x all over summation f. Okay, which in this case summation fx is 737, and then summation f is 50. And so when we divide 737 by 50, we will have an outcome of 737 divided by 50 is equal to 14.74. Alright, and so we go back, and so we can compute for x minus x bar. And so this is x minus x bar column. Alright, and so we start to subtract the mean from each of the samples data. Start to subtract the mean from each of the sample data, and we know that x bar being the mean is equal to 14.74. Alright, so we can say 9.5 minus 14.74. okay, so we do that for all the data points. We do that for all the data points, and then we will say 11.5 minus, as you can see on the screen, all you have to do is just to subtract 13.5 minus 14.74, and then you have minus 1.24. okay, and then it continues in that manner till we get to minus 5.24. and so the next thing we do is x minus x bar. okay, alright, there's a square here, and so we have to square the values from this outcome. Minus 5.24 times minus 5.24 is equal to 5.24 squared, which gives 27.46, and then we square 3.242. okay, when we square 3.24 we have 10.50. okay, and then 2 we square 1.24. when we square 1.24 we have 1.54, and then we square 0.76. when we square that we'll have 0.58. okay, you can use your calculator to do this squaring. And then when we square 2.76, okay, we have 7.62, and then we square 4.76. alright, we will still have 22.66. okay, so these are the outcomes we have, and then the next step is to multiply by f. okay, what we are trying to do is to find the numerator of what we have after to find the numerator of what we have is to determine the numerator value of our grouped data mean. okay, where we have that summation f of x minus x bar, okay, all squared. okay, that's the numerator we have there, and so all we have to do now is to multiply the frequencies by the mean squares, the difference in mean squares, this column multiplied by f. alright, and so we have 5 times 27.46 to be equal to 137.3. okay, and then we have 10.50 times 4 to give us 42. 1.54 times 12 is 18.48. okay, and so 0.58 times 15, the frequency there is 15, is equal to 8.7. okay, and then 12 times 7.62 will give us 91.44, and then 22.66 times 2 will give us 45.32. so for this column we add all the outcomes there, starting from the first outcome we add all the and so we have 137.3 plus 42 plus 2343.24. okay, so this is for summation f of x minus x bar all squared. All right, so now we can determine the standard deviation, the variance of the grouped data given there. We have summation f x minus x bar squared all over summation f, where that is the numerator there is 343.24, okay, all over summation f is equal to 50. Okay, we divide this by 50, and so dividing by 50 we have 6.8648, okay, which you can say is approximately equal to 6.86. all right, so that is the standard, the variance of the group data given, and then the standard deviation is the square root of variance. Standard deviation is equal to the square root of the variance, okay, which is as good as taking the square root of the outcome we have there, which is summation f x minus x bar all squared all over n. all right, so therefore standard deviation xd will be equal to square root of 6.86. all right, so we take square root of 6.86 and we have 2.62, okay, which is about 2.6192, and which is approximately equal to 2.62. all right, so this is how we determine our mean, our standard deviation, our variance, and so on for the grouped data. all right, so but if we want to determine the mode, okay, we shall use the following. The model class is given as the lower class boundary plus the frequency of the model class minus the frequency after the model class, okay, all over frequency of the model class, minus the frequency before the model class, okay, and then all in bracket plus the frequency of the model class minus the frequency before after the model class times the class width. all right, the class width for this particular group of data, from where we took it from the class width C, is equal to 2, and I want to believe that every one of us knows how to determine the class width of a class. And so when we go back to see what the lower class boundary is, okay, all right, the lower class boundary here of the model class, the model class, what did it define the mode as? We define the mode as the class with the highest frequency, and then which means the model class, as we have in this picture here, is 15, because 15 has the highest frequency, and so this is our model class. all right, and the lower class boundary of the model class is 14.5, okay, as lower class boundary. all right, and then the frequency of the class before the model class is 12, and the frequency of the class after the model class is 12. I think we can get these things together. 14.5 as the lower class boundary. Then we go back to our computation, okay, and so the lower class boundary is 14.5. all right, frequency of the model class is 15, frequency before the model class is 12, then frequency of the model class to 15, 12, all right, plus frequency of the model class 15 minus frequency after the model class 12 2, and we said the class size C is equal to 2, and so this gives us 14.5 plus 15 minus 12 gives 3, okay, here is also 3 plus 3 times 2, okay, so from this computation we can simplify further to be equal to 4.5 plus 3 over 6 times 2, okay, and so we can do these computations together. So we have 2 here is 1 and 2 here gives 3, all right, this gives 1 1, and then we have 14.5 as the outcome. Therefore we say that the model class or the mode is equal to 14.5. Therefore mode is equal to 14.5. all right. And so how do we find the median? The median is given as BC, where BL is the lower class boundary of the median class, okay, and then we have n/2 minus frequency of the model class, of the class before the model class, and then over FM, that is frequency of the median class rather, times C. Okay, all right. So how do we determine the median class? Okay, suppose we are given total number of 50 data points. Our data n is equal to 50. Okay, so we determine the median class by saying that the class that falls in between half of the class, 50 divided by 2 gives you 25. Okay, good. And 50 is an even number, so the 25th and the 26th number forms the median class. All right, let's go back to our table of values where we have our table, and then we can be able to discover which class is the median class. And to do this, we have to determine the cumulative frequencies of the table above. Okay, we have to determine the cumulative frequencies of our table, and I don't think we have cumulative frequencies here yet. All right, so we have to do that now. So how do we determine the cumulative frequency? I think we've done that in previous classes. You can check exercises on your statistics book 1. You can check where we had exercises on cumulative frequency. All right, but for the purpose of this class, we'll still repeat it. All right, we have frequencies 5 for 12, 15, 12, 2. Okay, so we have frequencies 5 for 12, 15, 12, and 2. All right, so you can easily find the cumulative frequencies. Cumulative frequencies are found by adding the first cumulative frequency, okay, is 5. There is nothing above to add to 5, okay, but below 5 there is 4. Adding to 5 you have 9. 9 plus 12 we have 21. all right, and then 21 plus 15 we have 36, and 36 plus 12 we have 48, and 48 plus 2 we have 50. And so we go back to our table, and remember we said that the number that falls between the 25th and the 26th number makes the median class, because the median class should be the 25th plus the 26th number divided by 2. And so let us check where the median class falls from our cumulative. Okay, look at this. The median class cannot be in 21. Okay, it cannot be at this point. All right, so the median class will surely be at the point where we have 36, because from 21 to 36 it must contain 25, the 25th number, and the 26th number inside 36. So we take 36 as the median class, and the median class is the one with the frequency of 15, and so we will denote this as our median class. Okay, the median class is this, and so we shall start to represent the values so that we can determine the median. Median is equal to, what's the lower class boundary of the median class? Is the lower class boundary there is 14.5. all right, you have 14.5 plus n is equal to 50 over 2 minus cumulative frequency, okay, before the median class is 21. all right, all of our cumulative frequency of the median class is 36 times the class width, which is 2. okay, And so we have 21 to divide 50 to give us 25, and then we'll have 14.5 plus 25 minus 21 all over 36 times 2. Okay, and so we saw further we have 14.5 plus 4 over 36. Okay, and then times 2. If we divide further, we'll have 14 going into 36 to give us 9. Is that right? Yes, 4 divided by 36 is equal to 9. Okay, and so we have 14.5 plus 2 over 9. 14.5 plus 2 over 9. Alright, so we can simply divide 2 by 9, and then we'll have the median to be equal to 14.5 plus 0.2222. Alright, so we'll add this to 14.5. The median will be equal to, therefore median will be equal to 14.72222, and so which is equal to 14.72. Alright, so this is the median for the group data we had previously. Okay, for this group data we have here. Alright, so in the same vein, we will use this group data to plot for the cumulative frequency curve. We'll plot the cumulative frequency curve, also called the OGIF curve. The OGIF curve. Alright, and so we shall call it the graph of cumulative frequency. The graph of cumulative frequency. Okay, alright, in this graph we plot the cumulative frequency against the class boundaries. Okay, the OGIF curve can be used to estimate or determine the various quartiles of a graph. Alright, so we'll plot as follows, and just like our normal graph, okay, it must have a heading, so always begin to note the name of the graph, okay, relative to what you are given. You can remember this example is for the scores of students in different subjects. Okay, so you can call this the OGIF curve of scores of scores of students. Okay, simply. Alright, but you can do better than this. Always try to find out the name of the curve you are plotting. Alright, so like we said, the cumulative frequencies here and the class boundaries on this side, class boundaries. Alright, and then the cumulative frequencies, we are a bit big, so I'll pick my points to start from 10, 20, 30, 40 and 50. So if I have 10, 20, 30, 40 and 50, and so at the origin I have 0. Now look at how I place my class boundary, unlike the way I did for the histogram. Okay, the same thing happens. My method does not change. All I have to do is to start to pick values from the way the arrow goes to down where it ends. Okay, and so doing that, I have my class boundaries starting from this point as 8.5, and the next value here I have 10.5. okay, and then the next value I have 12.5. alright, I have 14.5, then I have 16.5, then I have 18.5, okay, and then 20.5. Alright, so I think it's necessary I write their class boundaries. Alright, but I'm almost done with the job. Okay, but I needed to put their class boundaries here. But since I'm almost done with the job, let's continue that way. I just hope you understand. That's why I've been switching between slides so that you can understand actually what we're doing here. And so this implies that for the first cumulative frequency we have 9. That's for the class boundary from 8.5 to 10.5, from 10.5 to 12.5, or I think that's what we'll have there, right? And then plus from 12.5 to 14.5, from 14.5 to 16.5, from 16.5 to 18.5, and then from 18.5 to 20.5, okay, 18.5, from 18.5 to 20.5. okay, these are the class boundaries we had. Okay, I just included them so that we stop switching from one slide to the other. And so for the cumulative frequency we have at 8.5 to 10.5. At 8.5 to 10.5 we had 5, and the next 9. Alright, so at 8.5 to 10.5 we had 5 should be the midpoint here, and then at 10.5 to 12.5 we have 9. You can check your slides, you can write down the figures before we start. And then at 12.5 to 14.5 we had 21, and we look at the point where we can have 21 is likely to lie on this side. And then from 14.5 to 16.5 we have 36. This is 40, and a little bit in between, in between 40 is 36. And then at 16.5 to 18.5 we have 48. Okay, 48. Alright, 48 is almost close to 50. And then at 20.5 we have 50, and this probably gives us our OGIF curve. And so the OGIF curve follows. You start to join the lines, okay, to join these lines, and then the last line follows. Alright, so this definitely gives us the curve of the cumulative frequencies. Alright, so this is what we call the OGIF curve. Okay, alright, because of time we have to end the class here. Do have a nice day, keep reading and you will understand more. Good day.